let's talk about 7-1. This begins our lesson on the Pythagorean theorem, which is something usually everybody loves. It's a lot of fun to do, and it's pretty easy, so this is something that's going to maybe help make you feel a little more confident in your math skills. If you do not have paper, please get some and head it up like we've practiced with 7-1 notes at the top and your name and your date. And please make sure you're keeping your math papers in either a binder or a folder. You do not have to write anything down from this slide. It is our lesson overview. On the main right, you will see our 8th grade standards. Pythagorean theorem is part of the geometry unit, which is the G you see in your standard. This is not something you've seen before, but it is something you will see again. Geometry is its own class in high school, and it is a requirement to graduate. So it's not an optional class to take. So everyone will take geometry at some point, and you will see the Pythagorean theorem again at that time. Your objectives say, students will be able to, or I can, understand a proof of the Pythagorean theorem. And all that means is, are these values making it true or not true? That proof means you can decide, does this work or does it not? Also, students will be able to use the Pythagorean theorem to find the length of the hypotenuse or a leg of a right triangle. So that one has all kinds of goodies. There's lots of vocabulary there. We're going to look at those vocabulary in just a minute to figure out what they mean. Our essential understanding says the Pythagorean theorem can be used to find an unknown side length of a right triangle. So that little bit of information right there, that's kind of what this whole thing is about. I dropped my pen, sorry. Used to find an unknown side length of a right triangle. That's kind of in a sentence what the Pythagorean theorem does. Before we talk about the Pythagorean theorem, I would like to remind you of the lesson that we just completed. We just finished talking about square roots and cube roots. That information is going to be important as we complete problems on the Pythagorean theorem. This one says the area of a square is 81 centimeters. Find the perimeter of the square. Well, perimeter is distance around. So my perimeter is going to equal side plus side plus side plus side. I do not know the sides, but I do know the area of a square. So my area is going to equal 81 centimeters, and that's centimeters squared. That's kind of finding the square root of 81. Well, I know 81 is a perfect square. It comes from 9 times 9, which means that one side length is 9. So my perimeter is going to be 9 plus 9 plus 9 plus 9, or 36 centimeters. Can you tell that's an M? It's kind of an ugly M. We are going to be using that same theory of finding square roots from numbers that are perfect squares and numbers that are not, and being able to find the Pythagorean theorem. Okay, I would like you to listen first, and then I would like you to pause and copy down this information. So I have this right triangle. I know that it is a right triangle because it has this box. This is the right angle box. So Pythagorean theorem only works with right triangles. That's important to know. Now there are 6 things identified here in my triangle. There is capital ABC, and then there's lowercase ABC. Capital ABC, these are angles. That means they're going to have a number. I know, for example, that a right angle, if you remember from last year, is 90 degrees. Angle A and angle C are also going to have a numbered measure. My angles equal 180 when I total them up. Those angles are not something that I can find using the Pythagorean theorem. A, B, and C, lowercase, are side lengths. They are side measures. Those side measures are what I'm going to use for the Pythagorean theorem. You'll notice this one says the longest side, and this one says the shorter sides, not angles. So although there are 6 things pointed out in this triangle, I'm only going to be finding the side measures using the Pythagorean theorem. Okay, the hypotenuse, C. It is the longest side of the right triangle. It is also always located across from the right angle. Always. This side is always my hypotenuse side. My legs, A and B, and they are interchangeable. It doesn't matter which one you label A and which one you label B. My legs form the right angle. Okay, we are going to talk some more about these things, but I'd like you to pause and copy this down for me, please, on your notes. I have drawn a right triangle here. You will notice it's turned differently than the other one we just looked at. I do know, however, that it is still a right triangle because of the box. That box is really important. So this tells me that this is a right triangle because it has this right angle. I would like us to identify the hypotenuse. If you will remember, we just said that the hypotenuse is always opposite or across from this right angle. So if I extend my arrow, if I need to do that, I can. This side is my hypotenuse. It is represented in the formula by the letter C. If you will remember, I told you that your legs form the right angle. So this line and this line forms that right angle. They meet, they connect at that point to form that angle. So that makes this a leg, and that makes this a leg. Now your theorem itself, it says that a leg squared plus the other leg squared, and think in addition. You can add numbers in any order. So it doesn't matter which leg you start with, as long as you do not start with the hypotenuse. Those two things squared and added together are going to equal the hypotenuse squared. Now mathematically, we like to use a lot of numbers and symbols. My legs are represented by A and B, and my hypotenuse is always represented by C. So the theorem says A squared plus B squared equals C squared. So let's practice that. Let's practice finding the hypotenuse when we have been given the legs. This is our first example. You will either need a calculator or you can use the Desmos calculator online, and I did post a video of that. It is in your modules at the top under How To of where to find and how to use the Desmos calculator. I'm going to start with my theorem. I know my theorem applies to this problem because, do you know? I hope you said because it's a right triangle. I know if I'm looking for side measures in a right triangle, that is always Pythagorean theorem, always. So I have my theorem. A squared plus B squared equals C squared. Sometimes if you're not sure which is a leg and which is a hypotenuse, I think it's easier to identify your hypotenuse first. It is not connected to the right angle in any way. So it is this line. This is the only line in my triangle that does not touch that angle. So this is my hypotenuse. That's C. So 8 and 15, they can either be A or B. It doesn't matter. So 8 squared plus 15 squared equals C squared. And you will get the same answer if you put 15 in place of A and 8 in place of B. That doesn't matter. Okay, I'm going to square these numbers. I know 8 squared is 64 because 8 times 8 is 64. It's a perfect square. 15 squared means 15 times 15 is 225 equals C squared. I'm going to combine my 225 and my 64. I'm going to add them. I get 289 equals C squared. Now this is where my knowledge of square roots come in. I do not want C squared. I want 1C. So to get rid of that square, I'm going to take the square root. So I'm going to take the square root of 289, which is going to give me just C. That is just like when we had, we were taking the square root of 100. Well, I know that's 10. 10 times 10 is 100. Or the square root of 49, which is 7. So we are taking the square root of something, so it's no longer going to be 7 squared or 10 squared. Now it's just going to be 1C. On my calculator, I can do the square root of 289. Some of these will be perfect squares and some of them won't. This one is. I get a perfect whole 17. So that means this side is 17. Now my hypotenuse is the longest side, so I need to ask myself, does that answer make sense? And it does, because 17 is bigger than 8 and it is bigger than 15. If my answer would have been smaller than one of my legs, I automatically know it is incorrect. Now I can substitute to check it. Y'all know I'm a big fan of substituting. This is the proof part of my theorem. I'm saying that C is 17. So if I substitute my numbers into the theorem, then it should come out equal. So my theorem, A squared plus B squared equals C squared, where I said A is 8, I said B is 15, and now I have said C is 17. I'm just going to put those in on my calculator. I already know that 8 squared plus 15 squared is 289. I already did that work. So I'm just going to verify on my calculator that 17 squared is also 289, and it is. If it was not, then it would not have been correct. Whatever I put in, I'm proving that this theorem is true. So since those are equal, my answer is correct. Here's another example. You do not have to write the problem, but please draw the triangle. If you feel comfortable and you'd like to go ahead and pause and see how far you can get on your own, that's fine. If you just want to watch me work it out this time, that's fine too. We all learn at a different pace. I'm going to verify that this is a problem I would use with the Pythagorean theorem, and it is, because it has this right angle. So I'm going to start with my theorem. There's my theorem. The leg squared plus the leg squared equals the hypotenuse squared. This side across from my right angle is my hypotenuse. Now today we are only solving for the hypotenuse, but we will not always be. So it's important that you know how to figure out which side is which. I'm going to call A 9, but you could have also called it 20. Remember, those legs, they can be either. Now, the fewer calculations we do, the fewer opportunity we have for mistakes. So I'm going to do 9 squared plus 20 squared. I'm going to do that in one step. If you're not comfortable doing that, that's okay too. You can square them separately and then add them together. But I'm going to do this in one step, and I get 481. Okay, now I do not want c squared. I want 1c. So to get rid of that squared, I'm going to take the square root. Now this number is not a perfect square. Can anybody think of how I know that? On my calculator, I do not get a whole number. I get c equals 21.931712, and it goes on. Those dots, remember from last year, means that it goes on. We are just going to round to the nearest tenth unless it tells us differently. So the 9 is in the tenths place. The 3 tells me it stays the same. So my answer here is 21.9. And I know it is not a perfect square because it didn't give me a whole number. And as I'm just learning my skill, if I feel the need to check, I can. I'm going to plug into my theorem. I know my legs from before are 9 squared plus 20 squared. And now I'm saying that my answer is 21.9 squared. I already calculated 9 squared plus 20 squared to be 481. 21.9 squared is 479.61. Now my answers are not exactly the same. Is that okay? Let's think about that. In the last problem, I told you they should be the same. And in this problem, they're not. So have I made a mistake? Let's think about how I checked this. I used 9, which I got from here. I used 20, which I got from here. And then I used 21.9. which I got from here. However, 21.9 came from this longer decimal. So I rounded a decimal. Do you think that might change my answer? I hope you said yes. I rounded off some digits. In my calculator, I'm going to enter 21.931712, and I'm going to square that. When I square that, I get 480.9999913, which is definitely going to round to 481. So I don't want to discourage you from checking your answers, but I do want you to understand that if I've rounded a number, then the answer I get from that, this 479.61, if I rounded it, then my answer is not going to be exact. If I'm nervous and I truly need to check this because I'm not sure if I'm right, I'm going to want to go back over here to this long irrational decimal. And we'll learn what an irrational number is in the next chapter. But I'll need to go back over here to this long, more accurate decimal. 21.9 is a good representation of this decimal that I got, but it is not exact. So if I am relying on checking my answer, then when I square things, I need to know they're going to come out not perfect. And the more perfect I need them to be, then I need to go to the more precise number. I hope that makes sense. If that doesn't, please let me know. But if I round off some digits, then the answer I get is not going to be exact. Here's another example. I would like you to pause the video here, please. Draw the triangle and see if you can get an answer. It's okay if you don't, but it's important that you try. See if you can look back at our past examples and find for me the missing side in this triangle. I'm going to start with my theorem. I know this is a Pythagorean theorem problem because it is a right triangle and I have a missing side. I know that this missing side is C, because it is opposite or across from the right angle. It's not connected at all to the right angle. My legs are what connect to form this right angle. So I know that 10 and 23 are legs and C is the hypotenuse. I'm going to use my theorem. A squared plus B squared equals C squared. I'm going to use 10 for A, 23 for B, and then my C. So whether you square them separately or together, I need to square those values. And I get 629 equals C squared. And then to go from C squared to just C, I'm going to take the square root. Because I only want one C. Again, I know this is not a perfect square because I get a decimal. 25.0798724. And it does go on, but that's all my calculator will show. I'm going to round that to the nearest tenth unless I'm told differently. And C equals 25 point, the 7 rounds the 0 to a 1. Now, if I want to check that, remember, if I use 25.1, it's going to be close, but it's not going to be exact. If I'm looking for a more exact answer, then I need to use this longer, more accurate decimal. So if I need to check it, I'm going to start with my theorem again, and my legs, 10 and 23, and then I have my answer, 25.1. Now, I already squared my legs, and I know that they're 629. If I square what I think my hypotenuse is, I get 630.01, which is very, very close. Now, can you think of why this one is more than my legs squared? Why are they 629 and this is 630.01? Why is it more? Well, it was initially a 0 and I rounded it up. So does that make sense that since I rounded it up, the answer is going to be more? This was essentially, if you think money, and people can really visualize money, this is $25.07. Well, this is $25, and this would be a 0 if it were money, and 10 cents. So I've added 3 cents. And I know that doesn't seem like a lot, but it makes a big difference when I'm squaring an already large number. So that's the reason. This is close, but it's not exactly 629, it's a little more. If I wanted to be more precise, and I wanted to square the whole number, then it's going to give me 629.0000001. So it is 629. My answer is correct. But the reason this is a little larger, just remember, is because I did not use the exact answer. I rounded it up slightly. I wanted to throw in a word problem because you know I really love word problems. A soccer field is a rectangle. I'm going to draw it. If it's a rectangle, that's where I'm going to start. I'm going to draw the soccer field. Here is my rectangular soccer field. It is 90 meters wide and 120 meters long. The coach asks players to run from one corner to the other diagonally. So this is my diagonal. They are asked to run this. The question is, how far do they run? I don't know, but my soccer field, since it's a rectangle, is made up of 4 right angles. And since this is across from the right angle, I have essentially, by creating this diagonal, I have made 2 right triangles. And I am looking for the hypotenuse, I hope you said. So I'm going to start with my theorem. A squared plus B squared equals C squared. I'm going to use 120 and 90 for my legs. Sorry, I think my wrist was on the slide and it was moving. I know those are my legs because they meet to form the right angle. I know that my hypotenuse is missing because it is opposite or across from the right angle. I'm going to square my values. And I get 22,500 equals C squared. To get just one C, the opposite of having something squared is taking the square root of that. 22,500. And this one is a perfect square. I know this because I got a whole number. So that means the diagonal is 150 meters. And if I need to check that, I can. I'm just going to substitute it back into my formula. That would be my proof that it works. Okay, last thing for today, I want to review the key concept. I would like you to draw this, please, as the final thing on your notes, because this is super important to know what goes where. The Pythagorean theorem is an equation. It's an equation because it has an equal sign that relates the side lengths of a right triangle, a squared plus b squared equals c squared, where a and b are legs of the right triangle and c is the hypotenuse. So it's so important, no matter how the triangle is turned, you're able to find what's opposite or across from the right angle and what's connected to the right angle to figure out what's a leg and what's a hypotenuse, to know what am I solving for. Today we only solved for the hypotenuse, but we will start solving for legs next week.